Hello, everyone. This is Michael Gibbs. I'm the founder and CEO of Go Cloud Architects, and I am really excited. I'm here today with my good friend Pravin. Pravin is a big data architect with over 17 years experience in the database and the data architecture world. He's now a working cloud architect and a great friend. Today, we're going to be talking about big data architectures. Now, the reason I keep bringing in industry experts like this are as follows. There's so much confusion in the industry, the difference between a technical architect versus an enterprise architect versus a solution architect versus a cloud architect versus a business analyst versus a data architect. And when you want to build your career and you want a really great career, you need to have a laser like focus and learn exactly those things necessary for your career. See, the thing is these are big careers. These architecture careers pay as much as physicians and attorneys, and there's a reason for that. There's just so much to learn. It's that depth of knowledge that makes a big data architect so great. It's that depth of knowledge to be able to solve a customer's problem. So since in the architecture world, we're about solving problems, we're about improving business performance through the use of tech. Now, before we begin, I'll tell you one of the hardest lessons for me. See, when I went into tech in the beginning, it was because I thought tech was cool. I had the hat with multiple propellers on it. I had a house full of routers, switches, service because I love tech. That's me. In fact, in my house right now, and I'll make a video of it, I have 9 24-core servers that just happen to be sitting around running stuff for me. I've got, enterprise grade firewalls, IDS, IPS systems in my house. My house is all wired 10 gig, but that's because it's me. I'm a bit of a geek a little bit with tech. I love the tech. I mean, you take somebody that's a 25-year network architect and a cloud architect and an enterprise architect and a business architect, and their house sounds like a jet engine from the tech. But when you build your career, I want you to be so focused exactly what you love. I want you to be the best. And as I go through my world, I get to meet special people. One special person is Pravin. Pravin just has so much knowledge of big data and big organizations. And whether they be coming in from databases or streaming data, he's worked with it forever. So if you want to build a great cloud computing career, a great big data architect career, a cloud data architect career, or even a solution architect, you've got to have some kind of background as to what goes on. Now, I'll tell you right now, I am a cloud infrastructure architect. That's where my home is. The network, the data center, and the stuff that makes it run. That's where I love to be. But on an architecture team, you're only as good as your contact list. I might be Mr. Network on the cloud, and I am. But I also, understand how the security things are done. I understand how big data things are done. Now, I'm not going to specialize in it, and I'm not going to go from network architect to what Pravin is. But if I wanted to be a big data architect like Pravin, you better believe I would learn it as just as well as Pravin. And for that reason, when I have a chance to bring an industry expert on, I do to enhance your careers. So with that in mind, I have Pravin. Pravin, could you introduce yourself, and then we'll talk about what big data architects are, and then we'll do a couple of things. My thought is we'll do the following. We'll talk about what is big data. Then after we talk about what is big data, we'll let you actually describe, some big data environments and maybe whiteboard it out. And then because you're both a big data architect and a cloud architect, and you've recently made a transition from just big data to cloud and big data as an architect, if you want to share some experiences, that would be great. We'll save that to the end, assuming we have time, because I want everybody to learn about big data architectures from you. So Pravin, if you could tell us a little bit about yourself.
Thank you, Mike. Thanks for introduction and about your big data related and cloud architect related the topics. So yeah, hi everybody. Good morning, good evening, good afternoon, according to geographical location. My name is Pravin Dwiwedi. I have more than 17 years of experience in database as RDBMS expert. You can say after that big data, then cloud and big data, those things. I worked in several industry, big industry, and implemented RDBMS solution, then NoSQL solution, then big data solutions on-prem and cloud. So that is my experience. Now let's talk about big data, career in big data solution architect, big data cloud architect, uh, maybe how to take your career from RDBMS to big data or from RDBMS to big data to cloud, right? So one thing we will have to be very sure that whatever we are doing in database, if you're coming from database background, we will have to understand the database first, regardless of RDBMS or big data or NoSQL, operational big data, whatever, right? First of all, we will have to understand the database. That means overall core. I started my career with RDBMS programming. When I say RDBMS programming, it doesn't mean that I used to write Java code and C sharp code and Python code. No, I used to write queries, store procedure, PLSQL code in Oracle, trigger. Then gradually I got experience. I came across multiple projects, multiple databases, and I started to review the designing of the database. So you know that table, views, row, column, data types, foreign key, primary key, all the jargons, how that those things work together. I understood that after spending 3 or 4 years, I was able to say that, yeah, I can design the database. So I started to design the database. So that is called conceptual data modeling, logical data modeling, then physical data modeling, those kind of things. I learned that in and out of the database. Like, you know, the if you go to any city, you should be able to understand the infrastructure of the city, where to go, where is a station, where is airport, where is movie theater, like that, right? The same thing I understood in the database, how that thing work, how to connect from a station to airport, bus station to railway station, that kind of thing. I spent my 10 years in the database, relational database. Then I realized world is moving towards the big data. I first time heard about the term big data. What is big data? And yet I was curious. I was thinking, okay, data is 100, let's say 100 terabytes. It's database. When it crosses 100 terabytes, reaches up to petabyte, it's big data. But no, I was wrong. It was not big data. So big data was something about your velocity of data, your variety of data, and your volume of data. Simple. It may be a small size of data, but it is still big data. It may be very large amount of data, but it's still not big data, right? So when you have triple V, variety, velocity, and volume, then yes, you can say it is big data. Now, what is the importance of big data? Why big data is there in the market and so much noise, buzzword about big data, data lake, those kind of things? What is behind that? Uh, Earlier, business used to focus on the transaction. They, I think, 20 years back, they never cared about the deep analysis on the data. Whatever data was there, they used to analyze the data for the transactional purpose. Okay, what is the sale? What is the profit? What is the quantity? That kind of thing. They never got more than that in the data, and they focused on the transaction of the data. If you are buying something from Amazon, making sure you paid, then only you will get the item shipped, something like that. They maintain the consistency, integrity, those things. After that, corporate realized, oh my god, we have lots of data, now we can do something. If you started to navigate some product on Amazon and you added in cart, right, and then you didn't buy it, you removed from the cart, sometime what you do, you just explore the product, click on the price, you even didn't add the cart, right? Now what business can find the value in your navigation pattern, your sentiment? If business has lots of data, Amazon has lots of data, easily Amazon can identify that price is a problem here on this product, and Amazon can suggest seller, can you reduce the price, because Customer is not buying, customer is stopping after clicking on the price, right? Now you can imagine how many persons are navigating the Amazon website every day or every second and capturing all the mouse movement, click, 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 even not click, the mouse move event, right? All the data Amazon is storing, it's a enormous data, maybe exabyte of data, obvious, right? Now, how to do analysis on that data? That is where big data comes into picture. Now you need very huge machine, very powerful machine to process that. When I say powerful, it doesn't mean that you are going to use supercomputer, right? So you will have to divide your task to analyze the data, and then you will have to get the result, right? At the same time, you will have to make sure you are dividing the data, it is highly available. You are not going to lose the data, right? So multiple copies of the data. You will have to distribute the data. Let's say you have 10 records and your machine has only power to process 2 records. That means you need 5 machines rather than improving one machine to process the 10 record. You need 5 machines, and you will get data from 5 machines, and you will just merge the data and you will give the result, right? That's how big data works. So this is one use case of big data. And in this kind of processing, Hadoop came into picture, where you store your data on multiple nodes, multiple servers, and those are not expensive server. It's commodity server. It's a cheap hardware. It's not like your traditional expensive fancy server. It's very common server. You will have to distribute data across the nodes, across the servers. You will have to start the process. You will have to get the data from, get the result from that, from the data which is residing on particular server or on multiple servers. Get the result from that server, combine that result and give it to end user. For that, Hadoop framework developed something called map reduce programming, and it was very complex. And it used to give the result, but it used to take lots of time. It cannot be like near real time. After that, Spark came into picture. Spark works everything in memory rather than on the disk. Spark just distributed compute, means your query processing and your storage on two different systems. And it is easy in the era where we are talking about microservices. Everything is decoupled, highly decoupled, right? So that's why Spark got very popularity. It's a hit in the market right now. And if you are preparing for big data, you will have to understand the Spark. How does that work? You will have to understand the distribution of the data on different servers, on different machine. This is all about big data. Lots of things are there. Now, we talked about velocity, variety, and volume. I talked about this volume. If you have high volume, then you can split the data. Sometimes velocity, you are getting data from sensor, right? Or your iPhone, your smartwatch, Apple Watch. Those data now need to analyze. Who will do that? How it will happen? So that is called streaming data. And again, streaming data, part of big data, yes, because you are getting very high velocity, and obvious in within hour or 2 hours you will have like huge volume, that kind of thing. So you need real time analysis. For that also we are using big data. And as I said, Spark has feature to work on a stream data. Same thing. These are the basic things. If you thinking to make your career in big data, don't first think about the cloud like AWS, Kinesis Stream, Kafka, Spark, EMR, Glue. Now I am hearing in the market, people are talking a lot about that. Anytime people say, hey, why don't use Kinesis Stream? Why don't use Kafka, right? No, first of all, we will have to understand the core. Then we can decide, can SSH Stream, Kafka, Glue, EMR, or whatever, Azure Factory or BigQuery, MongoDB, DynamoDB, whatever. So we will have to understand the process and need. So whenever we want to think about big data, first of all, we will have to understand the data sentiment, variety, volume, velocity. Then we can think about the solution.
Praveen, I want to stop you there for 1 second. For those of you that are new to the tech industry and are new to architecture, I want you to really listen to what Praveen just said. We're going to evaluate everything before we pick anything. So the data, the velocity, what we want to do about it. So long before anybody mentions like the name of a service like Glue or Kinesis, the analysis has to be done to the architect. What is the best tool? And then someone like a Praveen can say, okay, there's a cloud native tool. Great. There's a cloud native tool, but it costs twice as much as this other script we can write. Don't use the cloud native tool. Or the cloud native tool is better, faster, cheaper. But whatever it's going to come down to is going to be what serves the customer and what is solving that problem. So Praveen, you actually hit such an important point. I wanted to make that obvious for everyone. You do the analysis before the design. It's that knowledge you have in you that enables you to do the analysis. You just didn't say Kafka because it's screaming or Kinesis because it's streaming. There was a lot that went into that decision. And then I'll
Yeah,
go back.
Mike, you're right. Thank you. So I used to get lots of questions and like people used to discuss the problem statement with me about big data or about cloud solution, those kind of thing. So let's talk about one simple use case. Someone asked me, hey Praveen, we have data on-prem there on our data center and we want to do analysis on that data in cloud. Can you provide the solution? Right? Very plain statement, no fancy term, nothing. Now, saying this statement, I cannot give the solution, right? Oh, you can go to AWS, use EMR, use Redshift, use Glue. No, I cannot do that. Think about again three terms: variety, velocity, right, and volume. Then you should ask the question, okay, what is the data source? Is it RDBMS or do you have in the file? Or are you getting data from the third party vendor? Or it's a live data, streaming data? What kind of data you have, first of all? Then what is your volume of the data? It's a petabyte you want to move to cloud? Or it's just right now, just you started like couple of terabyte data you have, right? Then you will have to understand, okay, uh, do you have any NoSQL system or Hadoop system? What do you have exactly? That kind of question will give you answer. Then you can think, okay, can I move that data through network, existing network, internet? Or shall we go through something like, okay, copy data in pen drive and push into AWS? Go to Virginia data center and give the data center guy, hey, this is our data. I don't have internet access. I don't have bandwidth. Just take my data, insert me in my AWS system, right? Something that we can do. So we can save our internet and time also. So mechanisms are there to transfer the data based on the data volume. So you will have to first understand that what is the use case, what do they want to do, and what is the existing infrastructure, like your business growth. Correct, Mike? You are very fan of the business growth, right? Hey,
Absolutely. Whatever you think it's going to be, it'll be 10, 20 times that somewhere along the line. And sometimes that's enough. If you think you need 3 servers, you need 300. If you think you need 1,000, somewhere along the line, you'll be at 100,000. So give it the growth. Exactly, Praveen.
yeah. So based on the growth, again, you can think about the service, think about the solution. So lots of things are there. Like you can ask, okay, you want to move data to cloud for the analytics, but who are the consumer? It's only data analyst or really data scientists are there, or really do your business users who want to only see the dashboard, right? Based on that, you can think about, okay, data scientist and machine learning, right? And we will have to think from machine learning perspective. What kind of data? Okay, what is your business route? Do you want to transform the same data to the cloud? You want to do some data profiling, apply some business rules, something there, then push into the cloud, or that kind of thing. Then you can think, okay, so warehouse, or data lake, right? I didn't explain what is warehouse, what is data lake, but two options are there to analyze the data. We will come to that point, like what is data lake and what is warehouse, how does that work. We can talk about that also. Lots of things are there to talk. But yeah, here our discussion doesn't mean to give coaching or technical training. So that's why I'm focusing on the solution architect, right? So big data solution architect. So these things are there. If you want to be big data solution architect, you will have to think from that perspective rather than thinking about what would be the data type, right? How many tables we are going to create, what is syntax for create view, create materialize view, create table, create index. We don't think about that. First of all, we will have to understand the client's, your end user problem, pain point. You will have to understand that. Then you will have to ask the question. Okay, you have a stomach pain. Okay, what did you eat in the morning? Right? Something like that. What did you eat in the at the night? For 5 days, what is your food habit? Now, did you suddenly change your food habit? Those kind of question, if you understand, then only you can think about the medicine or any diagnosis. The same thing happens with your solution architect. You will have to with client, you will have to think from client perspective. When I say client, the guy who wants to develop the system, to get the system, big data system, that is the client, your corporate. So those kind of thinking we need to develop. And for that, other than technical skill, we need soft skill. That is very important. So when I say soft skill, I learned from Mike, and thanks for that. I like categorize soft skill into many parts. Like one is your executive presence. That is for me, it's very tough. Still, I'm learning. I'm going through lots of video and trainings. That is one thing. Second thing, how do you present anything? Your like body language, your eye contact, your hand movement, your supporting documents, diagram, those things. That is another thing. Uh, Soft skill again, how politely you talk, even though you have executive presence, sometimes you get very stern, right? Harsh, very tough to deal some cranky CEO, right? But you will have to mold yourself that time. And where Mike explained that we should practice breathing, yoga, and those techniques are there. You can control your emotion, you can control yourself. If someone is hitting you intentionally that hey, I have knowledge and I have ego kind of thing, and hey, this guy, I'm going to pay this guy, so I can deal that guy according to my choice. Sometimes end user or the guy who is in front of you, they think like that. It's human psychology. I'm not criticizing anyone. Like people think that I am superior. Simple, right? So you will have to deal with that also politely. You cannot keep quiet. You cannot go defending what no. You are professional. You are going to give solution, right? So you will have to make sure that you are very good at that. How to deal those things. That is very important for uh, career in big data solution architect. That is more important than whatever you know technically and whatever experience you have, but you will have to have very good soft skill in that. People wants to listen, and the good thing is there in the interview, I'm talking about the interview, though it is training or it is recommended that emotionally intelligent, right? Emotional intelligence, and you should not think personally, you should think professionally. Don't include your personal emotion to judge the candidate, but unfortunately it's a human psychology. If you like the candidate, then only you hire the candidate. And liking the candidate, there may be many parameters, not only your technical skill, not only your soft skill, many factors are there. So while giving the interview, while preparing for the interview, make sure you are being liked by the interviewer. That is very, very important
Like,
because
and it's so important. I'm gonna hit that and bring that up. Likability is one of the most critical factors to both getting hired, getting promoted, and earning a higher salary. It is critical. And and Praveen's talking about the soft skills. I want to give a few examples of how when you walk into an organization and you found that they have a $3 billion technology system homegrown over the last 20 years, and you look at it and you say, what the heck were these people thinking? Um, if you're empathetic and you're truly emotionally intelligent, you can say, okay, I understand. First, the company did this. Then this company bought these 27 other companies. Then these 27 other companies also bought 27 other companies, and the organization had to do this adaptation, this adaptation, this adaptation. And if you walk in there and you're like, what the heck were you thinking? It's over. You're not solving things. So it's your ability to go ask those questions, the ability to ask open-ended questions in an open-minded environment where people don't fear judgment. That's when you get the information. Now, I'm not a programmer. In fact, I'm half architect and half medical professional. Like Pravin said, when you go to the doctor, they ask you a bunch of questions. And after they ask you a bunch of questions, they look through their knowledge base and they say, wait, you know what? Given this situation at this time, here's the diagnosis, here's the treatment plan. And as an architect, he does the same thing. He walks in, he asks some executives, what's going on in your business? Wait, you've been collecting all this data. That sounds great. What business problems are you having? What challenges do you have? And he thinks about what ways can I grow that business through the use of big data or through clouds. So Pravin, I think it's great. Now, do you want to walk people through maybe for about 5 to 10 minutes about how to design a data lake, what's in there with actual practical tools, whiteboard that out. And then maybe after that, you and I can do some questions and answers because you have so much to learn. And I can see people are out there, they want to ask questions and I want to do it. So before we get to that, if you guys can hit the like button if you're having fun, if you guys in the window can type hashtag cloud hired, we know you're alert and paying attention. While we do that, Pravin's going to sit up and he's going to whiteboard out what is the data lake. So, we'll let Pravin spend 2 minutes or 3 minutes talking about what is a data lake. And then after Pravin talks about what is a data lake, then he'll map one out. And I got to tell you, he's consulted with me on data lakes. He's taught me a lot about data lakes. And I've been in this industry for 25 years. So when someone like Pravin talks, I listen. So Pravin, if you can spend about 3 minutes on what is a data lake, and then let's whiteboard it out and let's ask you some questions.
Yeah, sure. Thank you, Mike. So before understanding the data lake, we will have to think about why we want to talk about data lake, right? Why people are talking about data lake. That is very important. So there are 2 ways or 3 ways to analyze the data, whatever data you have. One, very basic, we have table in Oracle on any RDBMS. We want to do some complex query and we analyze the data. That is one way. Plain system, no overhead, no special infrastructure, whatever data base you are working, you are inserting the data through transaction. On the same data you are querying. That is one thing. Second thing is there, you are getting historical data in some different system from your transactional data. Means on the database, your application is running from the same database, you are getting the data daily, pushing somewhere else and piling up the data. On that data, you are doing analysis. That is something called data warehousing. And generally, data warehousing is implemented through, again, behind the scene, RDBMS, relational database system. The only your data modeling pattern is different. They say like dimensional modeling, something like that. So that is one part. Nowadays, because we have varieties of data, like you are getting data from your application, you are getting data from your click stream, you are getting data from third party like Google Analytics, Adobe, something, third party data you are getting data from your security camera, you are getting data from somewhere like sensor device, motion, those things. Varieties of data are there, and obvious it's a high velocity, then volume will be very huge. You need some scalable system to accommodate that data, and you need some system to accommodate the variety of the data. That's why data lake, that's how data lake came into picture in the world. You are getting the data from different places and push data at one place, unified system, unified database. That is called data lake. It's very simple. Now, the difference between data lake and data warehouse, you must be thinking. Generally, data warehouse has limited capacity and some strict schema kind of thing where your variety of data is not too high. It's kind of a strict schema, predefined data nature. Those things are there, then your data warehousing is good. Now, variety of data, so we are moving towards data lake. That is different between data warehouse and data lake. Now, how to design data lake? Where to design data lake? Okay, one more important thing. If you feel that you are going to modify something in your existing data, then data warehouse is a good choice. If you think you are not going to frequently modify the data, then data lake would be your good choice. Now, we are talking about the data lake, we are talking about the update frequency and modifications, because there we are assuming we don't have use case for the data modification frequent data modification. Then we should go for object storage for data lake, where to store the data. So you will have to store data into data object data store, right? You can do on-prem, you can do in the cloud, because nowadays we are talking about scalability. So we will have to think about cloud. I have experience in AWS cloud, so I will take reference of AWS cloud for the solution. If you have expertise in Azure or GCP or whatever, you can just Google it. What equivalent of S3 and Azure? You will get like blob.
You get
Right?
Blob on Azure or cloud storage in Google. It's the same thing. It's the same service.
Yeah. So it's very simple. So I think it's very clear that what is data lake and what is data warehouse. We are going to think about data lake. Let me design the data lake. Uh, it's
And then walk people through each step of what every part of that actually is as you diagram it out. And then I'm starting to see some questions build up, and I've got lots of questions for you too.
sure.
And I would be if I was out there in the audience.
Yeah. So let me share that one very popular tool. It's open. Okay. So I want to share this screen. Okay. I hope Mike, can you see my screen?
Absolutely.
Yeah. Yeah. Okay. So this is app.diagrams.net. That is application. It's online application. It's free. If you want to design your diagrams, I think this is the best tool freely available in the market. You can use this tool. The best part, if you type like Oracle, okay, so it will give you Oracle related diagrams. Okay, so I'm choosing this. Okay, so what is our client requirement? We have data in the Oracle in our data center, and we want to get data from Oracle and create some analytic system. They will not say data lake, they will not say warehouse. Be careful. They will say they don't know actually what to use. They want solution from you. So they will say we will have to create the analytic system in the cloud, right? So they will tell you Oracle, or simply they will tell you we have database system, and you will have to ask Oracle, right? Maybe they will say MySQL. They will say we have some not something like that. Let me find something related to IoT. I don't know whether it's there or not. So we can say sensor, right?
My preferred way to do it, grab any box, knock it out, and then send it to the graphics team to do it, make it look really good in InDesign.
Yeah. So now we have very basic thing, Oracle, MySQL, and sensor data, right? From that, we want to create some analytics. Maybe many more source will be there, but this is good enough for the demo. Now, what we are thinking, okay, this is Oracle, this is MySQL, both are RDBMS, and this is sensor. This is in data center. What we should use to push data into cloud, right? So there should be connectivity between your data center and cloud. Few corporates use private line, few VPN, few is direct connect. Whatever is there, you should have connectivity between your data center and AWS. So assume that connectivity is there. Now, how to do that? A simple thing. Your left part is your data center, right part is cloud, right? So what I'm trying to do here, I'm trying to first get data from your data center to cloud. Then we will think how to create data lake. First of all, we will have to transfer the data. So there is some mechanism. I talked about a Spark, right? You get data, you process the data. Too many services are there in the market in AWS also to transfer the data from source to destination. Based on your use case, you can decide that either one-time data migration task is there, or there is the tunnel, like every time, every minute, every second, or in batch, you will be pushing data. I assume that it is batch. So you will have to write some code which can extract data. It would extract the data. So I'm extracting the data from Oracle. Then what I'm doing, if your client is saying that, hey, I don't want to extract everything into the cloud. I have some business rule, and that is called transformation. So you will have to transform your data, change the data, get certain data, modify some data, and then load into destination. So this task, who is performing this task, that is called coding, right? You say data engineering using a Spark framework. In a Spark framework, you can use Python, right? You can use a Scala, you can use Java, it's up to you, right?
Now, Praveen, that's
Now,
the data engineer, right?
yes. So
That's the
now
data
data,
engineer coding, not the architect.
yes. Now data engineer will decide what to use. Sometime architect also decides, but that's fine. We are not thinking much about that part. Now, once you are using that, where to execute and where to execute, it's our responsibility. When I say our, means our solution architect responsibility, I will say some Hadoop framework, right?
Can you make that text a little bigger, Praveen? Because it's a little hard for me to see, and I'm looking at the big ones, though, so I'm worried about everybody else.
Okay, let me try that. How to increase the font?
Just a touch bigger.
Is that fine now?
That's very readable now. I don't know if it's going to get in the way of what you need. So some hybrid is fine, or we can use that as great.
Yeah. So Hadoop framework. So architects should be able to decide Hadoop framework and what framework, because we are in the cloud, AWS, we need to choose some service there that is called Elastic Map Reduce. That is also called EMR. Okay. So now I'm architect. I decided that, hey, engineer, can you write the code to extract, transform, and load the data using whatever language you want, and you will have to execute that program on a framework that is called EMR. That's it. And hey, DevOps guys, infra guy, can you create one EMR for our engineer, for our use case? So now you can connect the dots. Where is your infrastructure engineer? Where is your DevOps engineer? Where is your data engineer? Where is your solution architect? So I am solution architect. I'm saying, hey, our engineer, dear, can you write the code, whatever language you want, using a Spark framework to to extract, transform, and load the data? And can you execute whatever code you develop on Hadoop framework? Wait, I'll give you Hadoop framework. Hey, infra guys, can you create one Hadoop framework using EMR and give us the endpoint? They will create the endpoint, and developer will say, hey, I got that. Like data engineer will say, I got the endpoint. Yeah, I can execute that. Engineer can test, data engineer. Hey, it's working now. Automate. Hey, DevOps guy, I have EMR available. I have code available. Can you automate that? End-to-end automation, right? So that's how.
Exactly. So I
Yeah.
want to highlight that out because this is where everybody gets confused when they want to be architects. People want to be architects for good reason. I love being an architect. I'm an architect, you're an architect, but you're not the one doing the coding. This is, for some reason, people have it in their mind that the architect is the person that's doing the maintenance, the coding, the design, the sales, the management, and everywhere in between. It is a village. So please listen to what Pravin has told you. He's telling you about data engineers. He's talking about DevOps people. These are people on your team. So please understand, one man can't do it all. One woman can't do it all. That's why they send in a SEAL team, not a single person. It takes a village to do these things. So I didn't mean to disturb you, but that's the biggest challenge I see with people that are aspiring to be architects is they want to do it all. And in the end, they learn all the things other than architecture. So sorry to derail you. And let you get back to what you're doing. For everybody there, hit the like button, type Cloud Hired if you're having fun, and let's go back to what you're doing, Praveen.
Yeah, so you are right, Mike. So I remember one, not one, couple of instances. I got like not offer. I got inquired by some hiring manager, not recruited, and they said that, hey, Praveen, we have some position for you, and it's a big data solution architect. I said, yeah, that's fine. I'm interested in that. And they provided. Then I said, can you please explain the JD and more your recruitment process and those things? And there was some coding round. And in my LinkedIn profile and in my CV, you don't see that I mentioned I am a programmer, I am a coder, because that has not been my career. I cannot write code for production. I can write code for POC, but not for production. And they said, no, you will have to go through coding test on Hacker Rank, Codelity. There will be one round of homework on coding. And I said, do you want me to code if I work as solution architect? They say, not really, but we need someone who has hands-on. I said, yes, I'm agree, but there should be some justification. Why do you want? No, our company process is there for any position. We do coding test.
AWS.
So coding test. I said, then I'm not a fit guy for your requirements, right? Sometimes you get that, you will have to deal with that. One of the companies I got selected for that, and clearly I said, hey, I do programming. I can understand the code, but for production, I am not the good guy. And he said, don't worry. Just we wanted to make sure you are aware of programming. That's it. We are not going to take any DS, Elgo coding test and those things. You are not going to write a code. POC, yes, you can write, but we have engineering team and they can do POC with you, right? I was happy. So yes, coming to the coding part, that is a gray area. Few people want, few people say it's okay, few people can compromise, few people say no, we cannot compromise. But that is the market. So this is the role. Now coming to the point, your team wrote this ETL task. Now that ETL task will be executed in EMR and load part. Where will it push the data, right? So it will push the data, the transform data into object storage, right? That is called S3. Again, I will have to.
I think we should probably use like a 16 point or an 18 point text for everything, and that way everybody will see everything without all the clutter.
Yeah. So S3. So you are getting data from all the different places using EMR and Spark code. So if you see, I'm just pushing arrow from all the source, right? Sorry. From the all the sources to EMR.
Now, if this was the data center, you would just be using one of those other tools, and you'd be using object storage, and everything would be the same, right, Pravin?
Yes. Now, based on your load, you can just copy it. So what I'm saying copy it means these things, right? Either you can use single EMR cluster, you can use multiple EMR cluster based on your data size, velocity, budget, right? Your operational team, what kind of team it is. Either you can use single EMR and to execute extraction, no, sorry, single EMR to extract data from all the different source, or multiple EMR to get the data. So just I'm giving example. Here are two, it may be 10, it may be one, but all of the data will push data into single place, that is called S3. You can say landing zone at AWS S3. So you are landing your data from diverse system to S3 to do some process. Now see, still I said that process is required. Right now, I am getting the data from source and landing into the cloud. So I am creating kind of repository, right? So landing the data in landing zone, that is on S3. Now, what is the usage of data? Do we need to perform analytics after combining all the three types of data from Oracle, MySQL, or Sensor? Or do we want to analyze the data individually? Sensor data, different use case, MySQL data, different use case, right? So based on that, we can decide from landing zone to some different zone, that is called data lake, the final destination. So let me put some more things here. I know space is less because of Zoom, but it will not be, yeah. So now we are creating here another S3 bucket, sorry, S3 in AWS, that is your object storage. And what we are going to do, based on the business logic, what kind of analytics or what kind of operations consumer want to perform. So I said this S3 is for analysis of relational data, right? So we will get relational data from our landing zone. All the relational data means Oracle and Microsoft MySQL data. We will perform some business operations, some business rules, and push data into S3, relational data. S3 means relational data lake, you can say simply, on S3. How to push data from your landing zone to final data lake, right? Here you will have to think about your business use case and what kind of process and what is the data size for the processing, that is called data set. Are you going to process 1 terabyte of data at a time, or are you going to process 100 GB of data at a time every 10 minutes or every 1 hour? Based on that, you select AWS service. And as a solution architect, you are very crucial here. Your role is very crucial here, critical. Either you can use EMR or you can use some other service that is called self-managed service, Glue. If you want, if you have very huge amount of data, EMR is recommended, Elastic Map Reduce. And if you have like few GB of data, I think 50 GB or 100 GB something, then better to use Glue. That is a service from AWS. Glue is the same as EMR under the line. The only difference is there, you will have to manage your EMR cluster. In case of Glue, AWS manages the EMR cluster. You don't manage that. You just manage your code, orchestration. That's it. Now, what I'm saying, we are pushing that data to data lake using, let's say again, EMR or Glue. Let's say I said Glue. There's a
So
reason behind that. Yeah.
So you got EMR or Glue, but for comparison purposes, I just want everybody to know it goes to my concept of drive the car. Don't get certified to drive a Toyota, get certified to drive a Honda, get certified to drive a Mercedes. If you took this exact design and instead of using EMR, you chose to use like a Python Spark script, and you could do this on Azure with Blob with that same script. You could do this with Google on cloud storage, and really nothing would change if it was a custom made script, right?
Yes.
So if it was a custom made script that ran on a virtual machine or multiple virtual machines, again, those virtual machines could be virtual machines on Azure's EC2 instances on AWS, compute engine instances on Google. It really doesn't matter. It's just you did the design. You said, okay, this is the data coming in. This is how we can map and reduce it somehow, either with one of the pre-made tools or making the tools ourselves. And then you put it into these object storage environments. And that could be any one of them. It could be the data center, object storage. It could be Blob. It could be cloud storage. It could be S3. That's what I wanted people to really understand is the cloud is really irrelevant which one you choose.
Yes. You are right, Mike.
Because I think
So
that's a hard lesson to learn initially, because it's like you learn the cloud, but you learned it, the data architecture first, and then you mapped it to the cloud.
yes, correct. Now, I chose here AWS Glue because already I explained the Elastic Map Reduce. So better to choose AWS Glue to explain this also. So as I said, down the line, under the line, it's Hadoop cluster. In case of EMR, you create the cluster, you choose the virtual machine, you decide the memory, you decide the CPU core, and you maintain that and making sure it is highly available, auto scaling is there, everything, right? Like you are buying your own car, it's investment. Now, in case of Glue, you are not buying your car, you just saying someone over, hey, I have 5 members in the family, one kid, I have to go to Niagara Falls from New York. That's it on the app. And it will tell you, okay, this is the best car for you. Just get that car. And you hire that car for 24 hours. Or Niagara Falls trip is done. You return that car, right? Means cab driver can go with that car. That's it. Your purpose is solved. The AWS Glue is same thing. You don't need to create your cluster. based on the requirement, based on the data size, AWS creates the cluster for you and execute your Spark script. Now, what is Spark script again doing here between S3 to S3? Why it is there? So in landing zone, you have data from different source, and based on the requirement, you are performing some operation on that data available in landing zone. What some operation? Okay, you have 10 rows. I need only 2 rows. You have millions of, sorry, I have 10 columns. You have 10 column. I need only 3 columns. You have million of rows. I need only 100K rows. That's it. Based on certain business rule. I I want that only. I want sale data from East Coast, not from West Coast. So that kind of transformation, you data filtering you perform and pushed into data lake. So the whole transformation you perform here, that is again you can say ETL, extract, transform and load using a Spark script. You push into data lake. Now this data lake has more purified data coming from different sources based on the business use case. Now, what you can do on this data? How consumer can consume this data? This data needs some shape, right? Blindly, you cannot perform any query, any operation on the data. So, in order to be giving the data to a shape, that is called a schema creation. You will have to create the schema. This is the column name, this is the column type, right? That kind of traditional whatever we know in Oracle or SQL. Same thing we will have to create here. And we will have to store that schema definition that is called metadata in some catalog, right? So let's say you created that definition on the top of the data and you are going to store that definition somewhere else. What is somewhere else? That somewhere else is called catalog. So what I'm saying, I'm taking the same glue. Okay, same glue. It may be same or it may be different, but same glue I'm taking here. And I'm not saying that ETL this time. I'm using glue as storage. Catalog at glue. So whatever schema you have defined on top of data lake, that schema definition you are going to store in glue. So basically, the role of glue, one role glue plays, it executes your ETL script. Second, it stores your catalog. Third, it orchestrates your job based on certain schedule. So 3 things you can perform using glue, right? So on top of data lake, I created catalog in the glue. Obvious. So there will be mapping between catalog and S3. How we can create the schema? That is role of data architect, right? See, I'm talking about the shape of the data. Even though big data solution architects do that, but there is someone called data architect, right? So data architect makes sure what is the shape of data, who can control the data, who can access the data, what data someone can access, everything about data governance, right? So that is data architect.
I'm
But
going to stop you
nowadays,
right there. Again, it's so important. A cloud architect like me will go to a cloud data architect or a data architect like Pravin. It's not expected for me to have any concept of this kind of knowledge. It's concept for me to know what a data lake is, know what the modules are of the data lake, and then go back to a Pravin. You can't be the doctor, the lawyer, the accountant, the electrical engineer, the firefighter, police officer, and Navy SEAL. They're all separate. So Pravin, I'll go back to you on that, but that's why he was trying to say this is not the cloud architect or the solution architect. This is the data architect. So please, everyone, focus when we build these architecture careers, focus on the one you desire. But know what everybody does and know all the Pravins out there because you're going to need them. Go back to you, Pravin.
Yeah. So yes. So that is role of data architect. So many things are there now. Security. You are exposing data. You are creating data shape. So you will have to take care of security also, right? There may be SSN data inside that, right? And who will take care of that data? As a solution architect, I can tell someone, hey, we need to take care of that data. But who is someone? Data architect. Maybe with security team, right? Anyway, so that's why we are using catalog and AWS Glue. One very important thing, your Spark and your Glue, both tools are enough, capable enough to create the schema, to infer the schema, to crawl the schema from your data. So what does it do? It take the sample, let's say 50,000 records from your the data, random records, and intelligently it crawl the data and say your data shape look like this. Is it correct? Then blindly you say yes. Then you can store into catalog. Otherwise, you can create by yourself that catalog if you know the business rule. So that is very important thing. But yes, there is a cost. If you say Glue or a Spark to get the schema, to find the schema inside the data, it will take some time, right? Because it will perform some operation on that. Anyway, so now your catalog is there. We know plain RDBMS query. Everyone knows. Whoever in IT, they know select star from EMP nowadays, right? Select employee name, comma, employee ID, comma, salary from employee table, right? For that, you need to have some credential on employee table, some access on employee table, and you can perform that query. And in order to do that, you need to have some kind of database engine, query engine. What I am saying, I am going to do some query, but I cannot do directly on S3 because S3 doesn't have any shape, data shape. Where is the data shape and definition? It's in Glue. So I will talk to Glue for my query. Hey Glue, can you give me something like this? Select from EMP, right? So what Glue will do? Glue will see, okay, this user has access on EMP, and what is definition of EMP? So EMP table will have corresponding data into data lake. So this Glue will see that query and it will go to S3 and return the data back to this client, right? Now, who is the client running this query? There are few couple of ways to do that. Either you can create your Hive system and use Hive to query the data from S3 using catalog, or if you want to use serverless, then you can do Athena, AWS Athena.
Now, Praveen, if they do AWS Athena and want to do multi-cloud, how does that affect it? As opposed to basically running it on an EC2 instance.
Yeah. So this is serverless, and you know the serverless will not work like cross cloud. It's a AWS proprietary, right? What we can do, something called Presto Burst. So you can create your own EC2 machines and you can install Presto Burst. I will have to double check the exact name. Presto. Let me check that name. Starburst, sorry. So what you can do, let me write it here. So rather than this Athena, right, you can use another service, not service, another tools that is called Starburst Presto. This guy you can install on your EC2 instance and query the data from S3, right? Whenever required, if you want to move from this cloud to different cloud, you can create your virtual machine and you can move it. Is that what, Mike, you want to know?
Exactly, yeah. So I just want people to know that, you know, if they're using a more generic service or doing it on an actual virtual machine as a pre-made service, if they want to shift from AWS to Azure to GCP back to Azure, they can do it. Or if they're running an OpenStack Ansible cloud or a Nutanix cloud in their data center and they want to spread it across clouds by using a more generic service, they can do multi-cloud very easily. I'm not saying that I don't love serverless. I do. It's just that I just want people to understand the benefits of serverless versus non-serverless in terms of vendor lock-in. Like if a vendor were to raise somebody's prices, for example, it's pretty easy when it's generic. And if an organization goes to the cloud and they love it, they can invest more in the cloud. If they don't love it, they can go back to their data center. They can switch clouds. For me, it's all about giving the customers as much choice and flexibility and giving them the best solutions. I just want everybody to know it doesn't have to be this. You could do any of these because multi-cloud is everywhere.
Yeah. And Starburst Presto, even you can use Hive. Now the trick is here. What is this Presto? Presto is an engine. So Athena and Hive both work on Presto under the scene. Now Presto has its own cluster facility also. You can get that. So either you can use Hive, Athena, everything goes to Presto behind the scene, right? So through Athena, you can do some query on your data lake, right, in AWS, or through Hive, you can do some query. Let me put it here. Based on use cases, right? If you have a small use case, you can go for serverless, but it will be expensive if you have a bigger use case. Now, what we will do, the query with query result, whatever we are getting through Athena or Presto, what we will do, query result, your business user is not going to read your query result. Your business user requires some visualization, right? Then again, what is a spelling of Tableau? Mike, it's my problem also.
With regards to which box you're going to use to draw the next picture?
Yeah, I don't know anything I can use.
Just use a box.
Yeah.
Just use a
See
square
if,
box.
let me check if it is there. No, it is not there. So I'm going to use some box here. So
famous designs have been drawn on napkin sketches in terms of boxes, and then we clean them up after that. But that's the form of brainstorming.
Yeah. So what Tableau will do, it will get SQL result from Athena and it will create the dashboard. So Tableau, I can say like visualization at Tableau. Or if you want to use serverless, means not serverless, I can say AWS service, QuickSight is there, right? So you can use AWS QuickSight, you can use Tableau, you can use Looker, you can use Qlik, you can use Kibana, Elasticsearch Kibana, right? Any tool you can use for visualization. Now, this is a basic data lake design, high level for, let me expand it, oh my God, for data analyst. This is not for data scientist. For data scientist, you can use something called SageMaker, or many services are there. So let's say example SageMaker. I'm not into machine learning, so I'm not talking too much about this. But yes, I know how that works. So here you can do some connectivity using Glue. You can use SageMaker, uh, a sorry, AI ML tool, whatever AI ML tool you can use on this Glue. So trick is only which part you have trick. You have trick here, right? Creating up to Glue data lake. Now, once you have created Glue catalog, AIML tool, whatever you want, you can use. Whatever query tool you want to use, you can use. Whatever visualization you want to use, you can use. So this is very basic requirement for static data or even real time of data for the data lake. I said EMR here for sensor data. See, I highlighted here. If you are going to a Spark, you can use a Spark stream here. That feature is there, Spark stream. If you want to use serverless feature or cloud service, then there is something called uh, Kinesis, right?
So for streaming data,
Yeah,
streaming data on cloud is Kinesis, on AWS is Kinesis.
yeah, Kafka,
Kafka,
Kinesis.
Kinesis, whatever.
Yes.
And that's really what I really like people to know is that you could use Kafka, which could run on any cloud. You could use Kinesis, which can run on AWS. So
Yeah.
lots of choices.
So nowadays Kafka is there with AWS also. That is called MSK. So Kinesis. Yes. Stream. So you can use Kinesis stream or you can use your Kafka, right? Means you can get your data from sensor to Kinesis stream, then Kinesis stream to again back to some ETL, then again ETL to data lake. The same thing. So you have two options. Either you can push sensor data through your own cloud independent tool that is called Elastic MapReduce, your own cluster. That also you can do. You can use cloud service Kinesis stream and push data into S3. Whatever you want, the options are there. So this is all about my high level of data lake design. What to think? Already I explained these many things you will have to think. What is your data? What is your volume of data? What is velocity of data? What is future growth rate? That you will have to ask before thinking about the design. What is your end consumer? What are the consumers? Only data analyst or data scientist also. If they say data scientist, then you will have to think about AI ML. If they say data analyst only, then you are good with Athena and visualization at Tableau. That's it. You will have to think about the size of the data so that you can decide, okay, Glue or EMR. You will have to ask, hey, what is plan? Are you going with single cloud or multi cloud? Or in future, do you have any plan to move through from AWS to Azure? If they say yes, we can, then you will have to try to avoid like Athena, Kinesis Stream, those kind of things. AWS Glue, those kind of things you will have to avoid, right?
Absolutely. So there's choices. So you know what, Praveen? There's been a lot of questions that come in.
Yeah.
So normally I would say close that, but you know what? I have a feeling that there's going to be a lot of questions on this actual diagram. So I'd say let's keep it up.
Yeah.
Let's keep it open. Chris is going to
Sure.
start popping some of these questions on screen. Before Chris pops the questions on screen, I'm being taught how to be Mr. YouTube. I don't know. I'm not a social media person, but I love that it can bring people together. So if you're here, if you can hit that like button, if you can comment and share, I think that is fantastic. On if inside of this window, like if you're having fun, like a cloud hire, just so way we know that you're actually here. So we're going to keep it open, and And at this point, let's bring in your questions. Chris will answer some questions, and we look forward to answer them.
Sure.
Mahesh, great question. Can you distinguish between a data engineer and a data architect? Is data engineering experience required to be a data architect? Pravin, I'll let you take care of that. But remember, for most folks, engineers do the work. We architects are the designers. We architects start with the client and design systems, and engineers typically build it, as rules in most forms of engineering and architecture. But in this case, Pravin, I'd love you to answer that.
Yeah, Mike, you are right. But nowadays, what is my experience? If you go for small organization, right,
Mm.
they want to perform all the role from single person. Whoever is the senior guy in the team, they perform all the roles, right? Because they don't have much budget to hire the different, and they don't have much use cases. So that is something, one thing I saw in the market, or I'm seeing nowadays. But coming to the point, standard practice, right? I'm not talking about the exceptions in a small market and a small company. Standard practice, data engineer and data architect, right? Uh, let's say orchestra team, right? So I don't know. So I know, or not orchestra team, music team. One is music director who arranges the music, right? Who come up with the tune, and then violin, percussionist, those want to just play it, right? Those are expert in their own field playing. Now the music director, they arrange everything. So on the high level, architect is that kind of guy who, it seems that he doesn't do anything, like he do like this. That's it. And when I was a kid, I thought, hey, what he's doing? Not doing nothing. But he used to do everything, running the show. And those musicians, those are guys are data engineer basically, right?
Exactly.
Correct. So that is high level difference. Now, data architect will talk about data, what will the shape of data, how we can ensure that data is secured, right? How we can ensure that data is highly available. How can we ensure that data is following your HIPAA compliance or MISMO or whatever, right? Lots of compliance, FedRAMP, many things are there. So who is going to take care of those things? Those guys are called data architect. It's not database architect, it's data architect.
Yes.
They take care of the data. Now design the data. So if we think from RDS perspective, data architect is someone who say employee should be one table, salary should be another table, right? In employee, you will have employee name one column, that should be a string data type. Employee ID should be integer data type. Employee date of birth should be date data type, something like that. And how salary is related to employee, right? So architects talk about the data. Now coming to data engineer, if you want to make, if you want to fetch the data from employee and salary table, right? How can you write the code? If you are getting the data, now how can parse that data, change the date format? Do you need salary up to the round figure, or you need salary in decimal? That kind of thing. If comma separated values are there, how to remove comma and give the values, right? So that kind of activity data engineer performs. Also, other than that, how to populate data into employee table, how to populate data into salary table, from which source? From consumer customer typing, end user typing the data and you are populating into database, or you are getting data from third party. So that is difference between data engineer and data architect. Now, data engineering experience required. Honestly speaking, nowadays data engineering is typical work for core programmer who is very strong in programming language as well as database, right? I would say if you have second part, you have very strong knowledge in database, good experience in that, you are good for data architect. But if someone has data engineering knowledge also means programming knowledge, it's good to have, right? You know both the things. Like you are driving the car, you are good automobile mechanic and you are good driver. That excellent. But in order to driving the car, you don't need to be a mechanic. Something like that. Think from that perspective.
And that's really the key. Driving a car and being a mechanic is great because if you're a mechanic and you can drive the car and you break down, now you know how to fix it. And the better you know that car, the better you know how to drive it. But training to be the world's best mechanic does not make you the world's best race car driver. They are very different things. So, underlying skills and knowledge absolutely essential. But, here's the key. Just because you're good at being a mechanic doesn't make you a good race car driver. And just because you're a good driver does not make you a good mechanic. So I still go back to, in general, train for the job you want and get the job you want. Because I've got to tell you, after training engineers to become architects and non architects to become architects, it's generally easier to train a non tech professional to be an architect from the architecture things because they don't want to go and code it. They don't want to go and build it. They want to go and design it, present it, do the modeling. Now, having said that, it's easier to create an architect out of someone that's got engineering knowledge because they actually have the knowledge of what's actually going on. So, I've worked with both, getting people with no tech background architect jobs and getting people with tech background architect jobs. They each have their challenge. Both are totally achievable. I do them both on a routine basis. For the deep engineers, it's teaching you how to think, not to do the coding and not to do these kind of things because that's what engineers do, not architects. For the non-tech people, it's building that sufficient depth of technical knowledge. Both challenges in both places. Praveen, I think you did a fantastic answer to that. Chris,
Yes, but I would like to add one point here. Uh, Sometime you should be capable enough to review the codes so that you are making sure whatever you thought or provided a solution, let's say data governance or encryption, that is being implemented using the best practice or not. So you should be able to understand the Python code basic. That my personal experience, I would say, that is required, but not like core programming.
and in that case, for these big data roles, I would say yes. For me, I still do evaluate the network that I see people designing. I look at the IP addressing scheme. Yes, I do. I look at their BGP architectures if somebody does it other than me. I might even look at the configuration, possibly, but not really. I'm going to be focused on the design. But the point is I'm an infrastructure person. We
Yeah.
infrastructure people are far from code. We security people, generally speaking, are relatively far from code too. But databases, data architects, this is all coding. So all these roles are going to be different, but still the architect is the designer, but you should have the knowledge to know what's actually going on. Basic knowledge. Again, basic knowledge. What the CCIE network engineer does versus what the CCIE network architect does are very, very different. Chris, if you want to bring in the next question. Zeta, what are the pros and cons of spinning up a Spark cluster under EMR to serve the data from a data lake? You mean if PB to me means lead, so I'm not actually sure what you mean by PB. Petabyte of data in S3. Just get the compute to the data. Okay, I'm trying to understand that. So any alternatives, Redshift, RDSL. So I'm not really sure I completely understand the question. Praveen, do you understand this question? It's Praveen, I think you're talking to a
Sorry,
muted.
yeah, yeah. Let me read it properly. Okay. What are the Okay, I got your question. So Redshift, RDS, and S3 data in S3, right? Uh, you are talking about data lake. So first of all, if we are talking about data lake and we have use case for data lake, Redshift and RDS cannot be alternative of data lake, right? Redshift is good for data warehousing. RDS is good for data warehousing. even if when do we take RDS? First of all, we will have to remove RDS from here, because if you need some transaction, then RDS is good, relational database system, right? So we are talking about Spark, we are talking about data lake, so no RDS, just we will cut it right now. If petabyte of data is in S3, just get the compute to the data. Any alternative? Your petabyte of data, EMR cluster can deal with your petabyte of data. I don't see any issue with the EMR cluster. Just only you need to make sure that auto scaling is properly in place, and whatever code data engineer has written the code, maybe like data frame or RDD, that's part of engineering thing, right? And whatever data structure, data dictionary, or whatever array, linked list, whatever they are considering in the program, it is up to the mark. So from that level to the cluster level, if you tune it properly, you petabyte data processing is very easy in EMR, because there is no single server who is processing on the data, right? It's a multiple servers in EMR cluster which will be performing operation on your petabyte of data. Think in that way. So it is in memory, it is parallel processing, massive parallel processing, MPP. So EMR should be able to handle your petabyte of data, whether that data sitting at S3 as source, or you want to push that much of data to S3 as destination. So you can do computation, high computation. You will have to select your tools or data structure, programming construct widely. Another thing is there, I think you can use Redshift Spectrum on top of S3. That is for query purpose, not for data engineering computation, complex programming language, complex business logic, data cleansing, not for those purpose. Redshift Spectrum you can choose just like Athena to read data from S3. I hope I addressed your question.
Chris, if you want to bring in the next question. And Chris will bring it up soon. He's got a pretty rough job. He's going through thousands of questions coming from everywhere.
Yeah.
Kenny Zhang, as handling of big data, we are bound to come across sensitive data. Therefore, can you share any common practices / approaches towards data abusification? Kenny, that is a great question. That's all you, Pravin.
Okay. Okay. So handling of big data. So I would like to discuss, because we are talking about the data security, right? Because of sensitive data. So we will have to think end-to-end data security, not only big data part, right? You are designing your big data solution in AWS, let's say, and you are getting data from on-prem. So nowadays, 99% cases, people are getting data from on-prem to AWS or cloud. So there only 10% maybe or 1% from scratch everything in the cloud, right? Security starts from the connection between your data center to cloud. That should be secured. That is one part. Using direct connect or VPN or whatever you want, SSL, you can discuss with your security team and they can suggest you this kind of data. This is the recommended, we will implement that. You can make sure. So at that level, you will have to make sure. Now coming to AWS, single sign on, right? Role based access, you will have to make sure that is there, right? IAM policy should be there. Security group level should be there, right? Firewall should be there. From those things, now coming to the big data. Now, data at rest should be encrypted. Whatever data you have kept in S3, it should be encrypted. That is one thing. Second thing, if you are using RDS, column level encryption you can perform either using your own key or using cloud key. AWS has KMS. That is very good thing. You can use KMS to secure the data, making sure no one is going to access that data, unauthorized person. AWS also has very good tool that is called Mackie. I don't know how to pronounce MACIE, something like that. Mackie, which find the sensitive data and it encrypt automatically for you. Like it will find your email ID, PII, PCI, those data, and it will encrypt. So these are the few way to implement the security for your sensitive data. So I mean to say on each and every level, you will have to make sure, other than that, make sure your data is replicated, your data has versioned, so something wrong, you can just pick it from previous version, backup and recovery should be there. Many things are there.
So, Kenny, I'll add a little to this because, once it went down the data abusification path, I was like, well, okay. And first, I hate the term abusification for the following reason. I remember getting out of my MBA program, and this is some cloud architecture development. I went to give her a presentation, and I strung a bunch of buzzwords together. And my executive coach, she sends me this book called Why Business People Speak Like Idiots. And it talks about how people and politicians answer questions they don't know, and they string a bunch of buzzwords together. And if you've ever heard someone talking, you don't know what they're talking about, it's because they don't know what they're talking about either, and they're using this technical term of abusification, stringing together stuff that they don't understand. And you'll hear it all the time, and then
I didn't understand that what is abusification and edification. I never heard that term, but I know we are talking something about data sensitivity and security, so I explained.
And Pravin, I love it. So Kenny, this is going to be like anything else. You protect the edge of your network with some DDoS protection, followed by a firewall, followed by an IDS, IPS system, followed by an access control list of some kind, followed by the equivalent of a security group, followed by your systems disabling the unnecessary services, being patched, for example, running host-based firewalls, encrypting your stored data, using a good IAM approach, and of course, anything else, getting your data to the cloud, either you're sending it encrypted or via private line, direct connection, whatever you choose to call it. And if you choose to, you can run IPsec or SSL-based encryption on that. I got lost at the word abusification because I know the business term. Kenny, we gave you 2 ways to completely secure down your data. I gave you my approach to architecture from the outside in. Pravin basically gave you the same thing, one step at a time. So Chris, if you bring in the next one, and thank you so much, Pravin.
No problem.
Afri P, Mr. P, can you have more than one query engine from different vendors across accessing the data? Is it viable for a company to create its own customized query engine?
Oh my God. He's talking like Facebook, right? Facebook developed or Google developed lots of query engines, right? Can you have more than one query engine from different vendors accessing? Yes. Is it viable for company to create its own customized? Yeah. So the best part of Presto query engine or MySQL, those things, those are open source. You know it, right? So yeah, you can take the source code, and if you want, you can customize according to your use case. And that's what Mike and I discussed, I think, 1 month back. Can we make RDBMS as like horizontal scaling? Can we infuse in RDBMS? And I said, Mike, I know Facebook is doing that, has been doing that with MySQL, but who knows what they are doing with MySQL source code? Like for us, we say, hey, MySQL is performing like thousands of petabytes of data, then thousands of nodes and horizontally scalable. It's MySQL, but we don't know. We never know what they are doing on the MySQL source code and what they have developed. So yes, we can do that. Source codes are available, and that would be best if you have good engineering team.
Yeah, if you always have the time, the effort, and the money, anytime you create customized, it's going to be far better than an off-the-shelf product, whether it be a cloud product or a vendor-made product. But what is the time of doing it yourself? First, there's no support. 2, you got to go figure it out. You need the staff of people. You need a lot of leadership. It gets real expensive. But you know what? It's like anything else in architecture. It may be cheaper to design your own than to buy somebody else's prepackaged if you use it a lot. So that's why when people say, hey, going from CapEx to OpEx is good, really? Well, maybe it's the worst thing for the business, or maybe it's the best thing, but it's up to you, the architect, to have that business acumen, to run that ROI modeling to truly help that customer make the best decision. Bring in the next question, please.
But yeah, Afri, that's a good question. Like out of the box thinking. I
Uh,
appreciate it.
and Mr. P, Alfred P, I know him. He's super smart, and I expected a kind of
Ah,
question like that. And what a great
thank you.
question. Jesse Murdoch, like and subscribe, folks. Please do so. We go live 4 times per week. Thank you so much, Jesse. Yes, we really try to come at you as often as we can, whether it's bringing in experts like Pravin or recruiters or executives over at NVIDIA or executives from Versa Networks or executives from everywhere. We try and bring in the best. So, you know what? Thank you, Justy. And you know what? The Final Destination, I love that. What a great song from a long time, probably before you were born, Jesse. Actually, I know it was before you were born. The final
Oh,
countdown, final kind of destination. But Jesse, I love the idea. I think you go ahead and implement it, and I'll subscribe to it anytime. Chris, if you want to bring on the next one, Jawad. A lot of info in this session. Go Cloud Architects looks forward to rewatching this. Thank you. You know what? I'm going to rewatch it too. You know, I feel very blessed to be able to speak to someone like Praveen. I know my world, it's the network, it's the business. I've been a network architect, a cloud architect, but most of my world is really enjoying that enterprise architect and that business architect world. You can take your architect careers any way you want. You can focus more on the business side and more on the technical side, and it's all great. So let's have fun with these careers. They're the best they can be. And I'm going to watch it again to learn more things from Praveen because I am not a data architect. I'm an infrastructure architect. I do love the analogy too. Thanks, Jesse. Chris, you want to bring in something else? Yeah, I agree. It was a really great analogy. Praveen is a poet. Yes. Well,
poet,
there you go.
technical poet.
He is a very wise man, and I totally agree with you there, Yvonne. Thank you so much, Evo. I know that's not exactly your name, but I know that's what we've been calling you for the last couple months, and we love working with you. Chris, you can bring up what's next. Abraham, is it required for a data engineer to have cloud-related skills? Well, and then I have a hard time answering this question, Abraham. And the reason I have a hard time answering this question, and I'll pass it to Praveen, is the skills that Praveen is talking about. Almost every one of them that he mentioned, the database, Apache Kafka, the Python Spark scripts, they're all things that can be done in the data center. And they're all things that you could do an identical version also in the cloud as if they're no different from the data center. But, Abraham, at some point, everything is going to the cloud because it's scalable. It enables us to be more agile, purchase exactly what we need instead of at the time as opposed to what we need for the biggest days of the year. So I see it all going there on the cloud. And the answer is I think you need some skills. For basic cloud skills, we have a completely free AWS Certified Solution Architect Associate course. It's completely free. Chris from my team will drop the link in here. We also have a completely free AWS Certified Solution Architect Associate ebook. Also, Andrew Brown has a great AWS Certified Solution Architect Associate course. It's free. You can find it on YouTube. He is free codecamp/exam pro. So those are two ways for you to get some really solid things. We also do a tremendous amount of free training on our YouTube channel. And if you desire to be a cloud architect, we have a program for that. If you desire to be a DevOps engineer, we're working with Sandeep Das for that. But I've given you 3 good resources to actually learn cloud skills. Now, Praveen, do you have any other suggestions for Abraham?
Yeah, so he's talking about what courses would you recommend for such a career path. So he's talking about data engineer, and
Yep.
obvious, ultimately everyone will have to move to cloud, and people are moving that. The one thing other than cloud data engineer, you will have to understand the data, right?
Mm-hmm.
So as I said, right, what is the source of data? Why do we use the data? What is the meaning of data? What we can do with the data, right? How data is arranged, orchestrated. So you will have to understand the data, then you can engineer the data, right? Connect the dots kind of thing. So Basic database you will have to understand. I don't say that first normal form, second normal form, you will have to go through codes commandment, not, but understand the basic database. What is the database? What is the data? What is SQL? What is data definition language? What is data manipulation language? Anywhere like 1 2 hours you can spend on YouTube or Udemy or anywhere, free course you can get on that. So that is very important other than your programming skill. So yeah, understanding the data and programming skill is very important for data engineer, like DS algo kind of code. So you will be very good in code writing, programming. That's it.
Okay, Chris, you want to bring in the next one? I know we don't have too much more time. Guess I'm not sure if there's any others. Pravin, from Derek Houston, your big data expertise is really on display. Absolutely, Pravin. Thank you. You did make it very clear, brother. You were so confident in this presentation. Derek, thank you. I completely agree, Derek. Pravin really made it very clear, and I was really happy to have him here. Mr. Reddy, you worked with Pravin before, and he is very knowledgeable. I couldn't agree more. I had the luxury and the opportunity to work with Pravin as he was transitioning into be a cloud architect, and I got to tell you, there was not a day that went by where I wasn't not only impressed, didn't learn something, and wasn't grateful to know Pravin. So completely agree with you.
Thank you, Madhuri.
Babita, you've done a lot of data engineering and of seismic data using your own industry software. That's very cool. So from where should I start to be a good cloud data architect? Well, Babita, the question is, do you want to be a cloud architect or do you want to be a cloud data architect? Because they're two very different things. If you want to be a cloud data architect, I'm going to answer the first half of it, and then I'm going to have Pravin go back to the rest half of it. I will tell you that for all architects, you need good business acumen because you need to be able to understand the problems you're going to solve. You must have exceptional soft skills, executive presence, communication skills, emotional intelligence to even get to the right questions in the first place. You must have excellent presentation skills because you're going to be doing a lot of presenting. You must have excellent writing skills. You have to have good ROI modeling. And I can tell you those are the things that all architects need to have. And anybody without that, no matter how hard they want an architect position, they can't get them. That's kind of the separation between the engineer and the architect. I'm not saying that engineers don't have these traits. Some do. But for an engineer, you are more technical. For an architect, you're at least half business. Now, let me pass this back to you so you can answer Babita's question as it pertains to the big data piece.
Yeah, so Mike, thank you. You are right. So soft skill, first of all, for all the architect is a very important thing, right? We need to have very good soft skill. Asking the question, that is an art, and that architects will have to develop on that. So asking the questions and presenting the solutions, right? Those soft skill is very important. Now, Babita is talking about cloud data architect. Babita, what I would recommend, first of all, you have very good experience on data engineering, so you understand the data. You will have to think, why shall we use cloud, right? First of all, you will have to start from there. Mm, if you think the problem statement, what is the source of data? Think in that way, right? What is the source of data? What is the variety of the data? Then you should be able to think in cloud. Let's say you have to transfer 50 petabyte of data. Then you can start to translate. How can we transfer that data into cloud? For that, what are the services available in the cloud? For 50 petabyte of data, AWS says that go through Snowball, right? Now, you understand the business and you will try to find out on the Google search and you will come to know, okay, something that is called Snowball. And then you can read about the Snowball, right? So understand your problem statement, and then think about the solution and then map it with the cloud. In that way, you can learn more faster rather than going through each and every service in the cloud and learn it, whether it's required or not for your use case, right? So if you see, there are more than 12, 13, 14, more than 14 databases service available, database services available in AWS. You are not going to learn all the 14 database services in order to prepare for your interview, right? What you will have to do, you will have to think your one of the use cases and what services required for that use case, that particular use case. List down all the services. Okay, I need DMS, data migration service, which will migrate data from on-prem to S3 AWS. That is one. Now, how we can automate it? That is something called data pipeline, or that is something called, many things are there in AWS. Find out that, right? Now, you will push data to S3. List down, okay, S3 we are going to use. From S3, we are going to push it to, then let's say, data lake. What you are going to use? Writing some code. What code I can write? A Spark. Oh, read about a Spark. Collect all the points, write down, as Mike suggested, what is a Spark, how does it work, why shall we use a Spark? Three things. My one, like, one more point on that, what Mike didn't explain to me, why shall we not use? That is also required, right, Mike?
Yep.
Limitations, right? So in the interview, people ask the question, why you are using EMR? I can explain, but why we should not use EMR, right? Because of cost, you need to manage, right? Everything. So that is also important. So for each and every service, just note down these points, prepare the presentation, and you are good. If you have time, do some hands-on. That is always better. So this is the way to prepare for data architect. Read about all the data service and don't forget the security. Everyone would like to hear something about security. They don't want to implement you the security, but at least you should be able to say, if PCI compliance, PII compliance, we should use KMS, we should use whatever, firewall, network access, whatever. They will not ask how many types of firewalls are available in the market, what is ingress, how it is egress, those kind of thing in security group. No one is going to ask. Just they want to listen from you. Security is required. That's it.
And that really is the key. Each specialty knows something. So I understand what a data lake is. And actually, Divya asked the question, if you want to bring it up there, Chris. And Divya says, for a cloud infrastructure architect, what level of depth of big data knowledge is required? Well, Divya, I can tell you this. I could call 1,000 friends of mine that are all Cisco certified internet experts that are working at cloud providers. And if I asked them to run an SQL query, they would say, how do I do that? So, in fact, it's funny. I remember one of the people that I coached that was working as an architect. He said, Mike, I now got promoted. I'm in the marketing department. I've got to run an SQL query. Do you know how to do that? He's like, because I asked, 30 other architects and 50 other engineers that are network engineers, and no one even knows what an SQL query is. So, Divya, there's two sides of it. You do need to know as an architect the things that are there. So Pravin needs to know what a firewall is and what an IDS is. And he also needs to understand what an access control list and a security group is, because it's there. As a cloud infrastructure architect, I need to know what a NoSQL database is and why it's used. I need to know what a data warehouse is. I need to understand what a relational database is and why it's used. I need to understand the concept behind data lakes, what data lakes do. I need to understand the tools, or at least that exist for data scientists, whether it be a tool like SageMaker or TensorFlow or PyTorch. I need to know what's out there. But that's all. When it comes down to it, the cloud architect, if you're a cloud infrastructure architect, is going to ask you about the network. And you're going to be your world. The cloud architect is going to be this generalist composer that's going to be saying, Pravin, what do I need to know about big data? Divya, what do I need to know about the network? Who else is on this call? Derek, what do I need to know about security? I mean, we're just a coordinator. In internal medicine, here's what my job is. Somebody comes in and I say, okay, you need the neurologist, you need the endocrinologist, you need the podiatrist, you need the ophthalmologist. And you know what? As an cloud architect, that's kind of what you're doing. You're basically bringing in specialties and aggregating people's information. So that's kind of the depth of knowledge you need to have. W, you got to be great at your world. But as architects, we need to understand the pieces and parts that get together for the solution. So I may be an expert at cooking Greek food, and I may know how to make a samosa, and I may know how to make some dal, and I may know how to make some lentils and bindi. I'm not an Indian chef because I know how to cook 4 foods. There are 4 foods that I absolutely love that I've had close friends teach me to cook over the years. So I know how to cook those 4 things. That does not make me a chef in another kind of cuisine. So it's a matter of just having the overall knowledge to know what goes on and being really great at your job, Divya. And I know you well, and I've seen how fast you learn and all the great things you're doing. So you're on the right track. Chris, if you want to bring in the next one, Buddha Singh. A lot of clients quite unrealistically expect a full-time developer to have some data engineering skills too. You know, this is really hilarious. We call this job inflation and job description inflation, and I'll talk about this in a minute. What would you consider bare minimum skills? So first, Mr. Singh, I got to tell you this. Job
Sorry,
description.
Mike, sorry. I know Bhuta Singh personally, and let me introduce
Okay.
here. He is co-founder and CEO of a company in Singapore, Workfall.
Okay.
And that company dedicatedly work on AWS services. So that is his introduction. And yeah, now you can go ahead, please.
And I really think that's great. Now, when I start looking at job descriptions, and I speak to hiring managers every day, and I speak to tech recruiters every day, when we start looking at these job descriptions, we actually assume HR wrote them. Because in some cases, they're so unrelated to the jobs that people actually do. In fact, in most of these cases, what we actually see is the job list every other skill other than the actual skill they're hiring the person from. So this is a problem. And, you know, Gartner Group actually, for example, started interviewing CIOs to say, what do you want in a cloud architect? Because the jobs were posting every other skill other than architecture. So it was published publicly. And yes, I expect a full stack developer to be, guess what? A full stack developer. And I expect a data engineer to have data engineering skills. And I personally don't assume a full stack developer knows anything about data engineering. And likewise, I wouldn't assume a data engineer would make a great full stack developer. I would think they'd be experts at coding databases and scripting and ETL tools and things like that. So that's my perspective. But Pravin, I'd love your perspective too.
No, you are right. The last statement, that what I wanted to explain. So first programming, second database skill, ETL, and nowadays the yes, even hiring managers are confused what to put in job description. They don't know really. They want Docker, they want Jenkins, they want CI/CD, they want DevOps, they want Dev Security, DevSecOps, right? That
Yeah.
DevSec. Yeah, those terms are there. They put everything, but when you go for the interview, basically they will first of all put one DS algo related coding test. That is very important. How to sort the array, how to find the duplicate record in the array, those kind of questions will be there, right? So programming is very important, understanding the data, that is very important. Now, how to use the new framework like a Spark, new tools, Kafka, those things are important, but core will be programming and database. That's what I would say.
Thank you for getting to that one, Mr. Singh. If you're coming from Singapore, that's fantastic. Actually, while we're at it, I'm looking at some of the countries and some of the flags. I know personally some people that are in India, some people that are sitting in Africa right now, some people that are sitting in Asia right now from the list. If you can actually put your country you're actually in the chat box, that would be really, really, really cool. Because we love to see how international these groups are. And then, Chris, if you can bring on the next one. And well, Mandar, Mandar, what level of statistics knowledge is required for someone that wants to work in big data? Okay, well, I will say this. I do know data scientists that need to know a whole lot about calculus and statistics. And I will also tell you that I am no data scientist. I have huge respect for data scientists. Anybody that can take all this data and glean it to give us information, I find is fantastic. But I am not a data scientist. I know a lot of them, though. In fact, I have a bunch of Quadro A5000 cards sitting around waiting for some of them to do something with them, because I think it's so great. Who knows? Maybe I'll take one of my young prodigies and have them do some data science things. And I've got some really good young prodigies. So, Pravin, if you can answer this on the big data side.
Uh, yeah, so big data is something like superset, right? Under that, you can work as like me, solution architect. Someone can work as big data engineer. Someone can work as you say data scientist. So for data scientist, you require that knowledge. For solution architect, really, I don't care that mathematics at all. Even data engineer doesn't care about the mathematics until and unless they are writing the complex algorithm for the data scientists, that kind of thing. So yeah, for like it's totally different thing. Big data is superset. Your that one of the use case, the domain kind of thing, math is there. The same like medical, right? You may have use case for the medical knowledge also in big data, reading your ultrasound data or your any kind of electronic device data, right? So yeah.
So fantastic. I'm seeing things come in. We've got people that are in the US right now, people in Sri Lanka right now, Brazil right now, India right now. And I'm looking at the USA, all over the USA, and I'm looking for some of these names. I'm looking at Alex, who looks like he'd be home speaking Greek just like me. So even though he's in the US, we've got Amrath in Canada. We've got Evo, that I think is in Hungary right now, even though she's from Bulgaria, which is always kind of cool and exciting. We've got Vinit that's in India right now. This is how wonderful, when I first saw social media 15 years ago, I said, why would anybody want to take a picture of their food and share it with the world? In fact, I use no social media because for me, oh, Leonard in Cameroon, I love this. For me, it was like, why would anyone do this? And then all of a sudden, I'm teaching a class to my friend Banjika's group in Cameroon, and there's 100 people on it. And now we've got Ibrahim in Helsinki, and we've got Jeannie, who's both attended from both Ethiopia and Las Vegas, and Ravindra in India, and Dibby in India, and Abigail in Asheville, North Carolina. To be able to connect this many people in a free medium to exchange ideas and help each other out in their careers, I got to tell you, but I first saw the social media 20 years ago, posting pictures of my dinner, to what you can actually do with this, connecting an expert like Pravin to people all over the world. I love it. I mean, I think that's amazing. If you're amazed by all of this, put big data in that chat box, because this is all big data. There's algorithms that are connecting all of us. There's algorithms that enabled you guys to find us. There's algorithms that enabled our content to be sent to you. There's algorithms that categorize our content. I mean, seriously, this is all big data, and this is really cool. Kenya, this is just really fantastic. So love seeing this. So wonderful. So Afri P, what are the general questions one should be thinking about when designing the data aspect? That is a wonderful question. That is the perfect architect question. Pravin is the perfect data architect. If you could answer that.
Hey, Afri. Again, so same thing I would like to repeat. Triple V, volume, velocity, variety, right? Uh, volume means what is the size of data right now and what is the growth in future. So that's come to volume. Velocity will tell you about it's a real time data, right? Or it's coming in the batch, that kind of thing. So you will have to talk about whether it's a batch data, real time data, near real time data, it's a historical data, too much historical. So generally in database we say hot data, warm data, and cold data, right? Ultra history, that is your cold data sleeping somewhere else in Antarctica or somewhere like that. Cold data not required. Maybe after 6 months, once in a year, you need that. There is some warm data. Time to time, you do some analysis on that, and there is hot data like real time data. So you will have to think about that. So that is velocity and that. After that, variety of the data. So whether it's a structured data, semi-structured data, unstructured data, uh, data is in JSON format, data is in XML format, data is in RDBMS, or data is in the file in CSV format. So you will have to understand those all the aspect. Then who are the end consumer of the data? It's some human being is there, or some application is there who is trying to consume the data. And security aspect, how to protect the data, that is very important. That also you need to understand what data we need to protect. Data classification is very important. That also we will have to think. I hope that is on high level.
I think that's really great. And you know, something something Ravender said that I just saw Chris pop that up, and I know there's some kind of a question. Yeah, I really love what Ravender said. If you pop this up, Ravender said that always feels so positive in these sessions, lots of brainstorming. And realistically, Ravender, that's exactly what I want to achieve here. I want you to truly understand that architecture is a team sport, that architecture is really not cut and dry. Like when you take a test and they say which one of the four is a relational database, and they ask you MySQL and they ask you MongoDB and they say DynamoDB and they say key spaces, that's cut and dry. You know the MySQL is the relational database. But when we're dealing with architectures, we've got 500 different tools to choose from and thousands of combinations that we can actually do it. And every business is different. So it's really a moving target. And what you have to do for one customer, you're going to do something different for another one based upon their needs. And because of this, that's why it's an art. You know, engineering is more of a science. It's still an art, but it's more of a science. It's consistent. If I go to a Cisco router and I type router BGP 65001, it's going to work. And if I type neighbor 1.2.3.4 remote AS 65002, I'm going to establish a BGP peering session because it's. But architecture is different. Architecture is me and 50 CCIEs sitting together for the next 6 months saying, how do we migrate your traffic to be more efficient? So it's all brainstorming. It's all getting together. The strength of you as an architect is the strength of your team. How many Pravins do you know from big data in case Pravin's busy when you call him and you're short on time? And you know, if you can find 3 Pravins in your life that are that good, you find them and you don't lose those numbers ever. And then you find the same 3 people for your security, 3 of them. Because, you know, 1 is none, 2 is 1, and 3 is greater than 2, because Pravin's going to be on vacation one day. And who am I going to call for big data? So I've got to have a backup. Pravin's my number 1, but you've got to have a number 2. And I encourage you to do that for everything. So that's why I do these sessions. That's why in our Cloud Architect Career Development Program, I have so many people from varied backgrounds and I bring in experts. It's because I want you all to know architecture is about brainstorming. It's about being the best minds that you can have to share their depth of knowledge. When I talk about not getting 10x AWS certified, there's a reason. The kind of knowledge that Pravin has in his head, that took a lifetime focusing on one thing. He didn't say, today I'm going to do big data, and next week he's going to become a web developer, and the week after that, he's going to become a network architect, and the week after that, he's going to be a security architect. He's great because he's been an expert on it. Simone Biles is the world's most decorated gymnast because she does gymnastics, more gymnastics, and more gymnastics. And she's pretty amazing. But you know, that's the key. So it's always going to be a brainstorming session, and that's what architecture is. So Ravender, you figured it out. You figured out exactly what we're doing, why we're doing. That's great. Chris, I know there was something you wanted to bring up. Please do so. Shakir, hi, I'm 44 and going to start a cloud career with Mike's Cloud Architect course. Wonderful. We look forward to working with you in case we already haven't started yet. I have some network knowledge. Good. That is hugely helpful. I have worked in operations in the administration field. Good. Can I please advise you in your new career? So, Shakir, and I know we spoke, I know you're over there in Sri Lanka, and I thought that was kind of cool when we spoke the other day, or was it yesterday? And for me, really, it's about you just following the program. It's about, you know, first building your career development plan. And that's why we have that number 1 right up there is, you know, finding out who you are and what you like. Why is the who you are and what you like and all the soft skills like the number 1 thing at the top of our program? because the journey to 1,000 miles begins with a single step. The best way to get to your destination is to chart a course. And we have to know what you love, know what you're going to enjoy before we can recommend a path for you. So as soon as we know that, and 44 plus is good, it's easier if you're older than younger. I am 44 plus as well. So I'm going to go out there and follow that. First, you will build your plan. Then we will pick a specialty for you, Shakir. It could either be a generic cloud architect, it could be a cloud network, it could be cloud security or something. We try to help you focus on one thing because we want you to be really great. And then, realistically speaking, it's going to be half technical to get you to your goals, but the other half is not technical. That other half of business acumen, communication skills, executive presence, emotional intelligence, ROI modeling, I got to tell you, that's even more important than the tech for architects. So the fact that you worked in operations, great, gave you some experience on how things work. The fact that you did some administration, great, you had a chance to configure things. Again, also wonderful. But now we're going to take the building and we're going to translate that into designing. And that's my advice for you. Follow the program. Today, so if you said you're part of the program, in 1 hour, we are going to be doing network architecture designs. I promise you it's going to be really fun. Today, the students will interview me just like they would a client. They'll work together to design. And of course, they're going to have to sell it back to me because, you don't just design it, you have to convince the customer. So that's the process. So if you join us today in the next 45 minutes, at least you'll get a feel for it. And welcome aboard. I know we spoke. I know you're coming from pretty far away. And welcome. 2009, MAMU. What is the difference between ML, big data, and data analytics? Well, that's an interesting question. I think either Pravin or I could answer it. I will answer it with my perspective, and I'll have Pravin answer it with his perspective. Machine learning is just a tool. It's nothing more than a tool that can parse through various sources of data. And the reason we run machine learning is to analyze data and be able to look for patterns in data and make recommendations or better guesses or inferences. So that's why we're using machine learning. Big data is basically the collection of all of this data, and data analytics is analyzing all this data that you've collected to make better decisions. But there's no point in doing big data without data analytics, because why else would we collect it all? But let me send that to you, Pravin.
I think same thing I would repeat. So data analytics, you can do data analytics on the plain data that is not big data. You can do data analytics on your big data, like huge amount of data, diverse of data, that kind of thing. And ML. So you can do analytics on plain data as well as whatever data machine learning got from big data. So you have data, machine learning got some pattern in that data. On that pattern, you can do some analysis. Simple. So that is your data analytics. I think it's clear now.
I think so as well. Great question. Glad you asked it. I see Shapur's in Montreal, Canada, by way of Persia, which I think is really cool. Brandon Bowman says, "Happy Friday." Brandon is a retired Marine. We thank him for his service. Brandon is an incredible security architect and cloud architect as well. We're real happy to see you here, Brandon. Happy Friday. AfriP, as architects, we are concerned about creating a solution to filter clean data, or is that data engineering? I think what Mr. P, AfriP, is talking about is, are we the people as architects that are going to create the solution for the data as a cloud architect? Obviously, as a data architect or a big data architect, you'd be designing these kind of things. But I'll let you kind of address this one because you're the big data architect.
Okay. It's not about filtering and cleaning or engineering the data for data architect. As architect, so are we talking about as a big data solution architect or as a data architect? That is hidden things here. If we say about data architect, then yes, we are concerned about filtering the data, cleaning the data, securing of the data, how to engineer that data. So those kind of thing as data architect. If we are talking about big data solution architect, then what tools we should take like maybe Hadoop, maybe NoSQL, maybe like Snowflake, maybe Databricks, that kind of thing. What cloud we should take, AWS, or we should go to the data center or Azure, whatever. So that is big data solution architect. So hope I
And I
addressed
think
your question. Yeah.
I think you answered that really well. Chris, if you want to bring up Brandon Bowman's Jack of all trades, master of a few, because that's different than the Jack of all trades and master of none. And I really want to address this. So, what Brandon's talking about is still being an expert. And I'll give you an example. So, when I was young and I was studying healthcare, I paid my way through the university by working almost 100 hours a week as an EMT and then a paramedic. And you know what? During those 7 years I went to college and graduate school, I got pretty good at being an EMT and a paramedic because it was 7 years. It takes a minimum of 10,000 hours to be an expert in something. So I was. And then after that, I went and practiced internal medicine for a little bit. Again, I went to school for this. So I had 7 years experience. I took a similar job. And then I said, wait, this tech thing is much more fun for me. And then I basically became a network engineer, then a network architect, and focused the last 25 years on this. This is great. This is career transitions. And, Brandon, whether he was been given directions, whether he was forced to run until he threw up, whether he had to carry a 100-kilo ruck for 20 kilometers a day, or whether he had to do some crazy obstacle course that would be really scary to create something like a crucible experience to produce mental toughness. Awesome. And then if after that he worked in security for a couple of years, he really learned security. And if Brandon now says, you know what, I'm going to take all my experience and I want to be a cloud architect focused on security, look at that. It's not really a jack of all trades and a master of a few. What do military folks do? They're security people. They help others stay safe. So he's got huge experience there. Now you take someone that works as a security engineer, security architect, and again, experience there. Now you take this person that's got a physical security background, an IT security background, and you teach them the cloud. Now you've got a cloud security architect. So anytime you're getting a specialty, you have to master one or two disciplines. But there's a difference between being an expert going step 1, step 2, step 3, step 4, than trying to say, today, I'm going to become an expert podiatrist or an ethologist, as someone that studies birds, a veterinarian who takes care of my beautiful cat Cindy, and I love my cat Cindy, as well as law, as well as accounting. That's insane. And that's the 10x AWS certified person, the jack of all trades and the master of none. Jack of all trades and a master of a few, Brandon, that is good. So, Chris, is there anything else? Otherwise, I think we probably need to wrap up pretty soon. I know Pravin's got to get back to work. There's lots of architectures that he needs to work on. I have a class to teach with a lot of really wonderful students coming on in a few minutes, but how often do we get a break, a Pravin here? So, Leonard Lash, how is Hadoop or Hadoop related to big data? And can you please explain the concept, please?
Yep. So I think already I explained the same thing. Let me explain it again. So when we say big data, right, it's all about volume, variety, and velocity of the data. High volume of data, how can you manage? Manage means how can you process the data? It's a very tough to process on the single server. So what you need to do, you will have to distribute the data and distribute the task, distribute the loads, whatever you can say, on different machines. You can break the data, split the data, and at the same time you're making sure that data is highly available. So you make sure that redundant copy of data is there on different machine. If you perform some query or some operation on the data, you would like to make sure that you're performing on the certain data, not like on full of the data, right? Let's say you have 100 data and the relevant data is only 5. Where do you want to perform the operation? So you would not like to go through the 100 of the data, right? Only you need to perform the 5 or 10, whatever required, right? If your data has been distributed in chunk of 5, 5, 5, 5, 5, right? uh, 20 nodes, 5, 5, 5 kind of things, your query or your process will target only 2 nodes where your data is there, right? Now, who will tell you that where is your data kept out of 20 servers, right? If you are going to get the data from there, let's say your data is spread on 3 servers, you will get data on the 3 server, you will have to combine it. Who will combine the data, right? Who will give you that data? So that whole framework is called Hadoop, and that technique under the line is under the scene is called map reduce. And you write some Java or Python code to get that. So that is big data and that is Hadoop, which perform these operations and manage the infrastructure. That is called Hadoop. Hope I addressed your concern.
Pravin, thank you for that. I really appreciate it. I do want to make one announcement today, and Chris is going to pop the link to it. We released a video on this question that people ask me every single day. Which cloud should I learn? Every day somebody asks me this question, and it's such an important question, and it can have such an impact on someone's career that we made a video on this. Chris from my team will put a link to that video in the chat box. I strongly recommend people watch that because I feel like it's very important. I want to make sure everybody builds their best cloud architect career, solution architect career, cloud engineer career, data architect career, or whatever it is that you guys love. So if you guys have had a good time today, if you can hit that like button, if you can subscribe and hit the bell to be informed of new notifications, new videos. Next week, I've got the recruiters coming in. And after that, I've got some other special people from lots of things. I would like to thank, the cloud architect, Pravin, who's also a cloud big data architect, who's also a big data architect, for your time and expertise. Thank you for sharing your knowledge. It's not that often we find people like you that are out there, and when you're willing to share your knowledge with the global community, it makes such a difference to build careers. Cloud architect careers, solution architect careers, big data architect careers. And when you've done this, you're doing this for free as a courtesy to help those in the world. I really hope the world can appreciate all you've done here, Pravin, today. I know I'm grateful. I know my students are grateful. If you're having a great time, if you've enjoyed this, if you can hit that like button and type cloud hired with a hashtag in front of it in the window, we know you're liking this, and I will bring in more and more and more experts in, because if I know you're enjoying the concept, I'll keep doing it. That's how we gauge whether you guys like it or give us comments and feedback. When you tell us we like it, we give you more of it, because we know what you need, but we want you to want what you need at the same time, so we can help you build your best cloud architect career. Because when people ask us, how do I get my first cloud architect job or my first solution architect job, we want to know we're here from you. We will get you cloud hired. Love working with you. Dean, thank you again for all your help today.
Thank
Derek,
you,
it's
Mike, thank you for that nice session, discussion, and thank you for all the participants. They are enjoying. I love that. I'm getting lots of thanks. So all of you, most welcome. And that's it. All the best for your career. Thank you.
Thank you so much. Look forward to speaking to you very soon. Appreciate everything, Pravin. Take care and thank you.
Thank you. Bye.